Welcome to EDU World Space.
Here's the problem 98 in chapter 19. Part A. Calculate the equilibrium constant for the reaction at 25 degrees. So we know that delta G0 of a reaction is equal to negative RT ln K. So we have ln K equal to negative delta G0 divided by RT. That's the equilibrium constant we're looking for. So delta G0 of a reaction is equal to delta G0 of the product, CH3COOH liquid, minus delta G0 of the reactants, which are the CH3OH liquid, and the delta G0 of CO gas. So this is equal to negative 392.4 minus negative 166.23 minus negative 137.2. That is equal to negative 89 kilojoules. So this is delta G0. So ln K is equal to negative 89 kilojoules divided by 8.314 times 10 to the minus 3 kilojoules per mole per Kelvin, multiplied by the temperature, which is 298 Kelvin, and this will give you a number of 35.922. So if we solve for K, this will be equal to 4 times 10 to the 15. So that's the part for question A. Part B. So in the industry, this reaction runs at temperature above 25. So how will increase in temperature produce increase or decrease in the mole fraction of the equilibrium? So this reaction, we have delta H0 of the reaction equal to delta H0 of CH3COOH liquid minus delta H0 of CH3OH liquid minus delta H0 of CO. So this is equal to negative 487.0 minus negative 238.6 minus negative 110.5. And that gives you a negative number of 137.9 kilojoules. So since the delta H is a negative number, so we know that the reaction is exothermic. So for exothermic reaction, when the temperature increases, the reaction is favored in the direction to the left. But they still increase the temperature. This is because when temperature increases, the speed of the reaction will increase. Part C. At what temperature will this reaction have equilibrium constant equal to 1? So if equilibrium constant equal to 1, we have delta G0 equal to negative RT ln K. So if K equal to 1, ln K will be equal to 0. So delta G0 will be equal to 0. So we also know that delta G0 is equal to delta H0 minus T delta S0. So when delta G0 equal to 0, delta H0 will be equal to T delta S0. So for this reaction, delta S0 is equal to S0 of CH3COOH minus S0 of CH3OH minus S0 of CO gas, and this is equal to 159.8 minus 126.8 minus 197.9 gives you a number of negative 0.1649 kilojoules per Kelvin. So now we plug in the number of delta H and delta S. We have the temperature equal to delta H divided by delta S0, and that is negative 137.9 kilojoules divided by negative 0.1649 kilojoules per Kelvin, and that is equal to 836.3 Kelvin.